applications, and as you can see, the research suggests that 75% of the organizations are suffering degraded applications. What I really like on this slide is the middle one, the Gartner one. And that suggests that we find out about it from our customers. And it doesn't matter whether those customers are external or internal, they're all our customers when we're with IT, right? It's really painful when you find out from an external customer. It's even more painful when you find out that management discovered this before we did. We're trying to get a hold of it. But it's pretty interesting here, and it suggests that the eyeballs that we have, the insight that we have, the analytics that we have associated with our internal applications aren't as good as we think they are, because it actually impacts outside or inside the organization before we find out about it. And then about a third of the time, we're unable to solve those issues. They're recurring issues. And it's difficult to pinpoint what those issues are, because we're not sure where they occur. Are they occurring in the infrastructure? Are they up in the cloud? Are they server-based? And so a lot of them sort of go on forever. And they may not pop up that often, but when they do, just sort of recapping, 3/4 of the companies out there have these problems. About 3/4 of them, or 70%, don't find out until an external user or internal user tells them that, and a third of them don't get resolved. So how does this manifest itself? It's not something that winds up in the data center and, well, that's IT's problem. It happens in the dark. We won't worry about it. Some of these things are very public. JetBlue winds up unable to take off because they have internal failure associated with delayed flights of the NASDAQ. I don't know that this happened in reality because one of the primary trading partners was unable to trade with the NASDAQ. They're unable to connect. Now, this wasn't you or I trying to do individual trading. This is one of the big giant trading houses. So shut down the entire NASDAQ. Was it millions? Certainly tens of millions, I'd imagine. 3 hours that the NASDAQ is shut down, so no one can trade, not just the partner that couldn't trade. And then, of course, well, we've got healthcare.gov. So after driving or forcing through the healthcare amendment in the United States here, the last thing that the government needed was a disastrous rollout, yet that's what they got. And the reason they got it was they didn't have insights into what would happen if suddenly thousands of users hit the site at the same time trying to sign up. They were unable to model it, they were unable to analyze it. And so we had a challenge, a very public challenge. And so what happens is it's not just that end users are impacted with this, there's careers at stake, right? This is very important. There's a lot of publicity that goes both internally and externally associated with any one of these three events. So what does it mean? What it means is these days it's impossible to differentiate or to disassociate applications with the business. You know, I've been around long enough that it used to be when I was gone, I got a little pink slip that said, while you were out, came back, oh good, I got some work to do. I was out. I got 2 or 3 calls while I was gone. Right? I had a typewriter, I had phone. That was even before phone mail. Now we've got applications that are customized to your business. They absolutely are associated with who you are and tied to how your business operates. And we all know what many of those applications could be. We've got SAP up there, Salesforce.com. I'm in sales here at the end of a quarter. Salesforce is in the cloud. I'm on it every day, you know, sometimes for hours a day, trying to adjust that. Our business is tuned to what the information that's in the cloud that's in that application. If our application goes down, we're out of business. We're down. It used to be, and I just made reference to the old days of how old I am, if our phone system went down, well, the phone system was up and the computer system was down, it was an inconvenience, right? If the phone system went down, we're out of business. Now it's the other way around. If the phone system goes down, it's an inconvenience. We've all got phones that, anyway, talking to a customer, but now if the computer system goes down, if the application goes down, even if the application is degraded, it impacts our business in a serious way. Let's take a look at sort of what traditional siloed. I love this slide because it's a little bit siloed. It's the way that things used to work from an application. You had the end user, you're working through the network, the web applications, and the infrastructure folks and services in the database, and everyone's managing, you know, their respective area. We've got the applications up. This is before it got too complicated. We've got a lot of solutions that come along with those solutions that we purchase. A lot of way to monitor those, a lot of independent point solutions that come from the platform providers that we have in our environments that allow us to troubleshoot those. But we have some challenges associated with that too. They don't talk to each other. They're not integrated. They don't allow us to provide a collaborative interface with the way that we might, we're good here, we're good here, we're good here, we've got a problem there. It doesn't allow us to talk. And so it creates an issue, and first of all, one of the things when an issue happens here, if it's really serious, what happens? War room. Anybody been in a war room or been asked to participate on a call all day long? And that usually doesn't come with a choice, right? It's a delightful experience. We've got a partner in customer in Chicago. If someone in Chicago drinks a Miller beer, this outfit delivered it. And as it turns out, good and fine people in Chicago drink a lot of Miller beer. And to the point where they calculate their downtime is $1 million an hour. $1 million an hour, so the good and fine people in Chicago really drink a lot of Miller beer. They had an ARP storm, resource planning storm, and they went down for 11 hours. 11 hours. I was a disaster. 2 hours into it, everybody's drinking Bud and Bud Light. You know, they're having a hard time. So the CIO calls the war room together. It took him 11 hours, so that's, even by my simple math, $11 million. So after going into the system, analyzing with them, working with them, just a little bit of a success story here, we were able to cut down. The next time they had an outage for the same reason, before the CIO could pick up the phone to bring the war room together, he got an email that the issue was resolved. It took 7 minutes. So, you know, we do some calculations. I think we saved them $10.84 million just by having insight and analytics on where that was happening, why it was happening, so that the team could go remediate the problem before it got worse. So, but this is what the old days looked like. Then we got just a little more complicated. Someone invented virtualized environments, disruptive technology. Someone put those in our infrastructure on the ground. Someone put those in our infrastructure in the cloud. It suddenly got very complicated. Not only that, we have streams of data running from our infrastructure on the ground to the cloud and back. It becomes more difficult to manage them. It becomes more difficult to understand certainly what's going on in the cloud. How do I track that? I still have to manage my performance. So manage my performance and understanding, getting insight and analytics into what's happening, both in the ground and in the cloud, much more difficult, particularly if we're still working in those siloed network point solution environments that we have, and we're using those tools. So what do we do with that? The riverbed methodology, taking a look at that, starts with the end users. We're going to go back to that slide where we said 70% of the time we're finding out about our problems from end users. Another example of that. Quick Trip, a convenience store outfit. They have about 750 stores. You know, gas out in front, convenience store inside. You get your car out, gas out for $50, $60, you go inside, buy. You know, it's lots of small transactions, but 750 stores generate about $100,000 every 10 minutes, right? And everybody's inside buying milk and eggs. They guess around 2 to 3 people in line is about how it should take, or about optimal, and what happens on the average when someone's in line to buy stuff when they're outside, you know, gassing up the car. As soon as that line gets beyond 3 people, they start to have a problem. Because people put down their milk and eggs, they go back to the car, they don't buy them, or whatever else they're buying. They were suffering degraded applications as well. And they can tell right away when that happens. All of a sudden, their $100,000 every 10 minutes clicks down to something less than $100,000 every 10 minutes. So it's pretty easy to understand, what the ROI is in that, but what the impact is on degraded applications. What wasn't easy to understand was they couldn't figure out why it was happening across 750 stores. So you walk in, 4 or 5 people in line, people turn right around, walk back out, they don't buy their milk and eggs, they're just getting their gassed up car and they leave. So we come in with an ability to take a look at, is it the network or is it the application? Is it an overloaded server or load balancer? What is the issue? Allow them to model changes they're making in the network so that they can see, or in their environment, where the problem is and what might be causing it. That allows them to not only fix the problem they had, but what happens if we open another store? What's the impact on our environment? So after we take a look at what the end user's perspective is, and maybe we get just a little bit of help on finding out what the problem is before our customers call us, there's 2 components that we want to take a look at. What does network performance look like? What does the application performance look like? In a common set of tools, not only in our infrastructure here on the ground, but our infrastructure in the cloud, and the route that those take. You might start on the ground, go up to the cloud, come back down to the, from the application folks, come back down to the infrastructure folks, and back out to the database again. So we have to be able to track that with a set of tools, a common set of analytics, a common set of tools. We just did some business with a big giant manufacturing company, global manufacturing company in Minnesota. So I asked them a typical question for application performance folks. How many mission critical applications do you have? The answer was, I don't know. I thought that was an odd answer because usually someone knows, right? We've got SAP, we've got shipping, we've got this, we have that. And the reason was you have 30,000 applications. 30,000. I mean, I have to say, my mouth dropped open on that when I finally got it shut. And so the reason I can't tell you what our mission critical applications are is there's so many of them, we can't figure it out. We get all this is the network up, right? We talk about network stuff. In the absence of light, right, there's darkness, and in the darkness, the network is the problem. So he says, we get all the calls. And so as a result of that, they're all mission critical. Can't define which ones are mission critical. We just have to fix all of them. And almost all of them are homegrown too, so they've sort of created their own alligators, and now they have to feed them. This is a big company that not only processes finished goods to consumers, but they do an immense amount of raw goods importing. They ship it from semi-finished goods from division to division. So they had a person who's responsible specifically for only the shipping worldwide, not only finished goods, but semi-finished goods and raw goods and so forth. Had no visibility into what the issues were. The biggest problem he told me we have is we have enough tools to be able to prove to our other to the database guys, application guys, everybody else out there, particularly infrastructure guys, it's not the network. So then it'll take us 2 days to convince them that it's their problem and not our problem. Why? Not a common set of tools. One of the biggest problems, right? Not a single source of truth to look back on. So what is it that we do that's just a little different? Whether you're a mobile user, which is one of the other dynamics in today's environment, we're all expected to respond in real time. I got an email from our executive vice president on the way over here last night. I live in Minnesota, as I mentioned. I was on the airplane. His expectation is that I will respond to him in real time. So I'm on go-go in flight, right? So I emailed back. So there's no off time anymore, right? The applications have to be up and running 24/7. I responded to him in real time on a plane. That's the expectation. No matter where I am or what I'm doing, I respond in real time. So it could be 2 o'clock in the morning. I'm expected to respond in real time. The applications have to be up. But not only do they have to be up, they have to be performing at peak efficiency so that everyone can do their job 24/7. And it doesn't matter whether you're on the ground or you're in the cloud, what application is, what server it is, or whether it's virtual or in your environment, is supposed to work at peak efficiency. So what are we? We've got software-defined data centers. We've got network-defined data centers, infrastructure, that kind of focus, this kind of focus. What Riverbed would say is, we support location-independent computing, so that your performance is the same whether you're sitting right next to the data center or whether you're home in your basement working from home. Location-independent computing, no matter whether it's mobile, whether it's on the ground, no matter where you are, how far away you might be from the data center, you have to be able to execute flawlessly so we can all do our jobs. Am I doing that on time? We in the neighborhood? Time okay? Make sure I don't. You've heard me mention this a couple of times, a single source of truth. Why is that important? It's the collaborative effort so that everyone's looking at the same data using the same set of tools across the environment, whether it's virtual or infrastructure, so that someone can't raise their hand. I'm not saying people don't get different views. You get the view that's associated with the area that you're in, if you're an infrastructure guy or a database guy. But either way, we're all looking at the single source of truth from one source so that our war room efforts will be more effective. I mentioned advanced analytics. What comes along with this is that modeling capability, right? And the ability from a collaborative perspective to also be, that single source of innocence, right? Hey, I didn't do it. And you heard me, how many folks, we got network folks in here, in the absence of a lot of capability to be able to do the analytics. Hey, the network's running slow. How many times have we heard that? It may not be the network. We have a mini value proposition here for network folks, right? We get you off the hook so someone else can be on the hot seat. The platforms associated with integrated management across Riverbed's full complement of products. That also includes our WAN optimization capability, the steelhead focus. You've seen that we recently came out with a new branding which created a platform. So the OpNet acquisition about 1.5 years, 2 years ago, and all the OpNet products are under the heading called Steel Central. And everything is Steel something utilized from that steelhead perspective. So the network performance management products, the application performance management products are all under Steel Central. Underneath all of this is a focus which is designed to provide tools to make it easier for us to stay up and running with a collaborative set of insight that provides not only optimization, but an ability to provide collaborative analytics so that you can be able to not only manage the environment better, but provide a modeling capability for growth. And that growth isn't always grassroots. Suddenly your company makes an acquisition, and you're trying to figure out how I can get eyeballs and insight into what that acquisition looks like. What kind of hardware, what kind of infrastructure do they have? How virtualized are they? Are they up in the cloud? Are they down on the ground? With the modular approach that Riverbed employs, right? You don't necessarily have to put a whole suite of products in across your entire environment. You can pick a spot where you think you're having the most trouble. You can pick a spot where you want to I want to really take a look at the network. I want to take a look at my applications. I want to be able to quickly deploy a set of solutions to an acquisition we just made so I get a feel for what their environment looks like. So you can absolutely add these different solutions on a modular basis, one at a time. But just by way of providing some qualified insight into how we do in Gartner's Magic Quadrant, these are both the network and the application Magic Quadrants, in which Riverbed is the only company that's resident in both of them. This is Riverbed out here and Riverbed here. So when I make the claim that we can provide you with these kinds of sets of tools and make your executive management, and there may be executive manager right here in this room, very happy because they don't feel siloed. They don't have to talk to 4 or 5 different groups across your environment because they have one set of tools that can give them the insight they need to be able to collaboratively look across the organization instead of the silos. It's not just us that's making that claim. It's outside analysts that are taking a look at the solution that Riverbed brings to market and collectively saying, this company is a leader in the marketplace because they're both Magic Quadrants. Additional recognition just from a qualification perspective. Probably don't need to go there, you know who those companies are. You know some really, really cool stuff. Another quick story, but Shell Oil has this giant knock down in the Gulf with a massive data center and screens all around. They've got like 30 screens, 29 of them are Riverbed. But it really does allow them to focus on their business with a common site. It's a great example of a single source of truth so people can eliminate silos and really get a feel for what their business is. They have the same kind of issue that revenue producing implications in the event that suddenly their oil rigs stop pumping, right? So they understand very much exactly how much that generates for them or costs them if suddenly an application that's running, they have 30 key applications, mission critical applications that manage the pumping on their oil rigs. And when those go down and when those get degraded, they know exactly how much it costs them. I'm going to pause for just a moment here and ask if there's questions I might answer. If they're really hard questions, Carl's here. You know, he answers the hard ones for me. You know, I get all the easy ones. Can I answer any questions for anyone? Yes, sir.
So we develop a lot of our own applications. How do you instrument applications, or how do you have to do an assessment of how they operate normally, or do you actually put something into the code to gather data?
So it's agent-based, and we are going to get right down. We analyze every single transaction down at the code level, you know, Java or whatever you have, and also create it's like we call it the Green River, right? So we understand, because we analyze every single transaction, what's normal look like, right? If you have regular peaks on Monday morning because everyone's back to work, we know that, we see that. If suddenly you have a peak on a Wednesday, right, then we see that that's not normal. So we do instrument it right down. Every single transaction, every single packet. So in other words, we're not modeling and saying, well, here's a set.
Right. My question is more about, I understand databases and network equipment, really easy to hook into and figure out as things are normal. But application servers where there's custom code,
What kind of code? Java.net? Yeah. So our agent will, because it's a framework, and it's a common .NET infrastructure or framework, we'll call it, we know where those hooks are. So that's why we can't go down to the code level. So if you're running like a compile code in SAP, for example, you can't, right? Because they don't expose it, but in your world they do. So we have an agent that resides on your web tier and on your app tier, and you can put it on the database tier if you choose. And it's going to pull, as Mike was describing, all your class and method statements, right? So it's going to monitor your CLRs, and it's going to look right into there. And then from there, then when he's talking about the behavior aspect, from the end user aspect, we'll also see what is normal versus not normal. In the development world, you're going to see every transaction. Every single one is going to come to you, big data format, and you can mine through it, just like a Google Analytics. Pretty different. You search on whatever parameter you want. Okay? It's, if you have any questions, contact one of the Marinum guys.
Okay.
A lot of people are running that now.
Just speaking of the hooks, do you guys have hooks for applications like other ERPs like PeopleSoft or Oracle?
We don't. We don't have a mechanism for decoding that, right? They don't expose it to us, so we don't have a way to do it. Now in that mode, what we do is we use a packet story, right? All we can do then is what we'll call fault isolation. We'll determine what tier or what container is the delay, but I can't then go to you, and I can pull in your machine data, CPU memory disk, and I can put all this into that single source Mike is talking about, but in that case, I can't get to the code, so all I can do is point to who's the offender. Instead of a war room, who's going to come to the situation? So we just had a situation down in Cleveland where we ended up at it was an F5. It was an F5, and it was load balanced, and they were moving between 5 different, and we were able to determine it's this F5, but we can't determine what the code is doing, but then as it turned out, it was an F5 config issue. But what that did is they took 11 months of finger pointing, and at least it got down to Yeah, 5 grand, which is funny because that's owned by the app team and the network team, so they still had to come to the table, but we were looking at a single container. And it took 11 months down to, less than a week to figure out. So that's how we work in those environments, so we can cover both.
Is there an agent that goes on desktops so that if you have different branch offices, small offices, as users pull down information from, say, a central office, they can almost form like a swarm, so that they can share those pieces of cache data so that they don't have to keep from, and I'm speaking from a WAN optimization point of view.
Oh, yeah.
So that they don't have to keep on pulling that data, a stream of something, a common big file that they're pulling down, some sort of,
So Mike and I are on the performance team, but we work with our counterparts, and actually Jim Schmidt will be here. He's running a little bit late. He's the engineer on the acceleration side. You're probably talking either using our appliance-based or virtualized-based acceleration platform, or even our mobile users client. So we have a client that runs.
well, it would be nice not to have to buy an appliance to go at every location.
Then you're probably looking at like a mobile user, which we could and put that, and then it'll act as its own WAN optimization endpoint. Right now, I don't know the details behind it. Jim will be here.
You're saying Jim Appian.
Yeah.
Okay.
So there is a way to handle that client side.
And I guess the other thing is, have you guys moved over into the security realm where, you're not just looking for optimization or looking for slowdowns in certain pieces, but also breaches and, issues going on?
We'll see breaches because it shows up in what constitutes other than normal,
Yeah.
right? And so we're not,
But you
right,
have
so
a
we'll
way to
identify
send
them, but, other than that, the data that we're sending, if we're sending up to the cloud is compressed and deduplicated and encrypted in terms of what we send, but we're not acting as a security.
Right, okay.
Yeah, we're not going to do your intrusion detection. That's a layer. The Marinette guys do that well. What we do is because we see the behavior on the network anyway, we can do what we call anomaly detection. So we can determine, you can do things like, well, if I have hosts that are, new host on the network, or a host is kicking off a span that shouldn't be, I should have a set amount when I have more. All of those things aren't going to say, hey, here's the virus definition, but it'll point to for the network team, hey, there's something going on that we don't normally see. Let's investigate.
Well, have you guys partnered with, other companies like a SourceFire or whatever, just to say, well, we're aggregating the data, now let's, shoot it over to these guys?
Well,
Well,
actually, that's where Gigamon comes in.
There you go.
That's a good segue. So I'll give myself the hook here and introduce John. We have a great partnership with Gigamon, and they're